The Intake Manifold Runner Control System, or IMRC, is a sophisticated engine technology that optimizes performance by precisely controlling airflow through the intake manifold. Here we can see the IMRC system highlighted in red within the engine bay. This system consists of several key components working together to control airflow. This technical diagram shows the IMRC components in detail. The system includes the intake manifold tuning valve, the runner control solenoid, and various sensors that work together. At low RPM, below 3,000 revolutions per minute, the IMRC runners remain closed. This creates higher air velocity, improving fuel atomization and increasing low-end torque by 15 to 25%. At high RPM, above 3,000, the runners open to maximize airflow volume. This reduces restriction and increases peak horsepower by 8 to 12%. When an IMRC system is stuck open, the runners remain open at all engine speeds. The system loses the ability to close the runners when needed for optimal low RPM performance. The symptoms of a stuck-open IMRC include reduced low-end torque with 20 to 30% power loss, poor idle quality, check engine light activation, and decreased fuel economy by 10 to 15%. Common causes of stuck-open IMRC include carbon buildup on runner flaps, broken actuator linkages, malfunctioning position sensors, and electrical wiring problems. Modern systems are electronically integrated with the engine control module for real-time monitoring. Understanding IMRC systems is crucial for diagnosing performance issues. When stuck open, these systems significantly impact low RPM operation and overall engine efficiency. Diagnosing an IMRC stuck open condition requires a systematic approach using modern diagnostic tools and procedures. The first step is using an OBD2 scanner to retrieve and analyze trouble codes. Focus on specific IMRC-related codes. Next, perform a thorough visual inspection of the actuator motor, linkages, and wiring harness for any signs of damage or carbon deposits. Perform functional testing by monitoring IMRC position with a scan tool and conducting actuator command tests to verify system operation. Once diagnosed, repair solutions range from cleaning carbon buildup to replacing faulty components, depending on the root cause. Carbon removal involves disassembling the intake manifold if necessary, using specialized intake cleaner or walnut shell blasting and lubricating pivot points. Component replacement costs vary by part. Actuator motor replacement costs $150 to $400 in parts plus 2 to 4 hours of labor, while position sensor replacement costs $75 to $200 in parts plus 1 to 2 hours of labor. In some cases, software solutions may be necessary, including ECM reprogramming with latest calibrations, position sensor relearning procedures, and system initialization protocols. Successful IMRC diagnosis and repair requires systematic testing, proper tools, and understanding of both mechanical and electronic components. When properly diagnosed, repair success rates exceed 90%.